See, multi-table queries. So generally when I talk about multi-table queries, is nothing but a queries which helps you to access the data from multiple tables. If you remember in the very first session, I was talking about RDBMS. In the RDBMS, what it says is to avoid the redundancy, to maintain the consistency in the data, identify the groups, make it a separate table, identify the keys for that, and define the relationships. Fine, that is what we define. Now, since the data has been spread across multiple tables and it is being stored to avoid the redundancy, to maintain the consistency, but when you're generating the reports, we might have to pull the data from multiple tables and show us one single output. Okay, so which can be like, say, example, I want to see the products with the category name, with the supplier details as one unit, or like, when the customer is placing an order, I want to know the customer details with their order details. Okay, so I need to combine the data from multiple tables and I have to show the output. That is where exactly we go to the multi-table queries. Now in SQL, what happens is we have different techniques to pull the data from multiple tables. We actually have 3 techniques to pull the data from multiple tables. So the 3 techniques are, so we have is joins. Okay, so what it does, joins combines the columns from multiple tables. It combines the columns of multiple tables based on the common relationship. There should be at least one common column between both the tables. Okay, based on which it links and tries to extract the data. Then we do also have a subqueries. Okay, a subquery is a query encapsulated within another query. So here what happens, first a query gets executed. Based on the output of that query, another query is being executed. Okay, we are subdividing the task into smaller tasks and we are telling that the queries are being executed in a sequential manner. Fine. So we'll be looking into that. And we also have a union. See, in the case of joins, you're combining the columns of 2 different tables. Okay, but in the case of unions, okay, you're combining the rows. Like we have the information from the different department. I want to combine together and I want to show as one single output. Like we have the sales in the say North region, we have the sales data of the South region. As a director, I want to see both the sales together. So I want to combine both and then I want to do the analysis on that, the queries on that. So we use this particular union operators. Fine. Okay. Now first, to start off, we'll start off with the joins. As I said, the joins are used to combine the columns of multiple tables and show us one output. So in this session, we'll study with the concept of joins. Okay, we have different types of joins. We do have an inner join, we do have an outer join, we do also have a self join. So we'll see one by one, how do we write this joins. Joins are used to retrieve the data from 2 or more tables based on the logical relationship between that particular table. So we need to have a logical relationship, means at least there should be one common column between the tables. See, common column doesn't mean the same name column. So names can be different, but the data type, the data, what it contains should be similar. Okay, so based on which we can define a relationship. Now take an example here. When you look into this particular data, here I have the department details. We have a department ID, the department name, location. And we do also have this particular, the employee details. Now what happens is employee works for a department and each department, there might be many employees working or there might be many employees working for the same department. So when I say many employees working for the same department, for all those employees, okay, the department number, the department name, the department location, who is heading the department. So the various details of the department will be repeated. So to avoid the redundancy, we have maintained this separate department table. And in the employees table, when they work for some department, we specify which department they're working for. We just mentioned which department they're working for. Okay, that is what. So, so that means we can see here, there is a common column here called as department number and the department number. Based on this, we can link and we can pull the data from multiple and show as output. And you can see when you use a joins, what exactly happens is we are just getting some data from this particular table. And also we are getting some data from this table. And when you are getting this data, when I say 10 is accounts, so that means it links here and it says Henry is working for this accounts department and he is earning 2,500. So you can see the data is. Now what happens here when the data is being fetched, Okay, so it is linking this department number to this department number and fetching the matching data, and based on that, this data is being merged and it is trying to show the data. Okay, so that is what happens. Now, when I say department 20, okay, says banking, it is in Boon. So that means we have two employees here. Alan is working for department 20, earning 3,000, and Drum is also working for department 20, earning 3,500. You can see department banking, we have Alan and Drum, so they are working, they are earning 3,000 and 3,500 respectively. So we can understand clearly that we are linking between this particular common columns and then trying to extract the data. Fine. Now let us see how do we do this particular things with our sample data. So since we are using the Northwind data, so with the help of Northwind data, we'll try to see how do we write this particular joins. Okay, I've just opened my SQL, so where I'm just going to use the Northwind database. So right now we are familiar with these tables like products tables, no? So I just take up this particular products table here. Fine. So this is my product data. So when you look into this particular product data here, we have a product ID, we have a name, supplier, and you can see we have a category ID, we have a supplier. Suppliers are supplying. So if I maintain, there will be many products supplied by the same supplier, and all this, which company say he's supplying, who's a contact person in that, what is his designation, where the supplier Gordon is located. I need to maintain that information, and it will be repeated for all these products. It's been supplied by the same supplier. And you can see there are many products again belonging to category 1. Okay, so the category ID, the name of the category, the description of the category, the image of the category, so will be repeated. To avoid the redundancy, we have made a separate category table, separate what you say, the supplier tables, and we are just linking it here. Okay, fine. So this is the data we have in the products. Now what I want is, I want to see, I want to get the information. See, we say Chai and Chang belongs to category 1, but I don't know what is category 1. I want to have the more detailed information. Oh, this is belonging to beverages, or this is condiments, or this is seafood, or whatever it is. I want to get the name of the category. So that the answer, the results can be more explanatory, more presentable. Okay, so for that I want to combine. So for that, what I do, I'll just go to my categories table. Select start from, so we have this categories table here. So when you look into this particular categories table, so you can see here, it says category 1 is nothing beverages, is a beverages. The description of that, there is an image associated with that. So every category ID has a name, a description, and an image associated to that. Cool. Now when you combine this and see, okay, it is two different queries altogether, is it? Okay, so now you can see that Chai and Chang belongs to category 1. That means they are nothing but beverages and this to this. And when I just talk about this particular products, so what is that product? These products belongs to category 2. So category 2 means is nothing but condiments. It can be something like this. Okay, so that is what I want to relate. And so I don't want to keep comparing manually like this. I want to show the output. So 1 means, okay, it's beverages. Beverages means it can be a soft drinks, coffee, teas. Okay, so I need to combine the data based on this particular common column, that is your customer category ID. That is what exactly I want to do here. So if I have to do that, what is that I will do? I'll just say select. I want to get the data, is it? I say from. What are the tables? So I'm going to get the data from 2 tables here. What are the 2 tables? I just say products table and categories table. Fine. That's it. Okay. So let me run this. You're getting the output here. So you can see here, we have all the products, okay, belonging to category 1. Okay, where is this one? And you can see even the category details are shown. But here what exactly is happening is, it is showing all the products belonging to beverages. Irrespective, you can see we have products belonging to category 1. We have products belonging to category 2. But at the end of the day, what it says, oh, it says it belongs to, all of this belongs to category 1 only, which is beverages. I say no. If you just drag down, you can see all the products belonging to category 1. Then again, all the products belonging to category 2. Means what is happening here is, okay, the compiler here, SQL, is combining the data from both the tables and showing. But here we have not told how these 2 tables have been related. we need to clearly say these two tables are related based on the common column. What is the common column here? Category ID. Okay, based on that. So I need to specify the category ID. So I'll just say where, how we find out what is the common column. So in the products table, I'll take the category ID. From the categories table, I'll take the category ID. So instead of repeating that column names, I can just give something like this. I can refer products as P. I can refer categories as C. So I can say here, since I'm just doing alias name there, I say P dot category ID. Taking the category ID from the products table, I'm linking to category ID of the categories table. So that's it. Okay, so when you look into this one, now we can see here, so this chai and chang belongs to category 1, that means they belong to beverages. So we can see here, this particular syrup and all this thing, they belong to category 2, that means they belong to condiments. Okay, we are getting the data. So now what I want to say, I don't want to get all the details. I just want to get some selected data from the products table and only some selected data from the categories table so that my outputs can be more clear and more readable. And I see it is always better to get only what is needed than showing the complete data and things. We have a lot of unnecessary data, it becomes difficult to analyze it. So, so what I will do is from the products table, I'll try to get say product ID. I'll just select, I want to get the product name. I say I want to get the unit price. Say, fine, I just want to get this data from the products table. I say from the categories table, I want to get the category name. And I also want to get the description. I'm just trying to get some columns. You can see here, this columns from this particular table. Okay, and I'm trying to get this category name and description from the categories table. Okay, some of the columns from this, what is needed, we'll just try to get that. And based on this comment, that is relationship where. And now we can see your output looks more better, telling that, okay, this is the products, what I have, they belong to so and so category. The products with the category details. Fine, this is how we try to do a join. For a join, we just specify, select from multiple tables. We say, what are the columns you want from these two tables and how these two tables are been related. Now, I want to show even the category ID. Like I say before category name, I just want to show the category ID here. Okay. Now what happens here? As I said, the product, this particular details, the product ID, name and unit price we are getting from the products table, and category name and this one we are getting from the categories table. But when it comes to the category ID, it is there in the products table. It is there in the products table as well as it is there in the categories table. Now, if I just say category ID here, the compiler has a confusion from where should I pick the category. Okay, so that is the reason you can see I'm getting an error here called as ambiguity or ambiguous column name. Okay, the reason is this same column name is present in both. So I need to clearly mention. So get it from the product table and then map it, or you get it from the categories is one and the same. You will get this out. You can see. So this particular products belongs to category 1. So that is nothing but beverages. Example can be like this. I say this is the products which belongs to category 2. There are nothing but condiments, which can be sweet, savory, sauces, and so on. This is how we relate it. Clear? Yes, all? Okay. Now, what happens? The other problem in this, see, it's very simple. We just need to say select what are the columns you want from what tables. So we can see instead of writing multiple tables, we are writing instead of writing a single table, we are writing multiple tables with a comma separator. And how these two tables are related, we are using the where clause. Now the challenge here comes, see, when you're writing a select statement, we know that where is an optional clause, it's not a mandatory clause. Is it? So if you want to filter, use a where, and if you're not using a where, no problem. It will not filter, it will show the data. But here we are using a where for joining the condition. And since the SQL compiler knows that where is optional, if I'm not giving the where clause, it will not throw any error. The query will work. What is happening here? It's not showing an error, but it's showing a wrong output. You can see it says, even though this particular product belongs to category 1, 2, 7, 8, or whatever it is, it says no. Because it doesn't know how it has been related. So this is a kind of a drawback of the SQL statement. So for this, what SQL has done is they have reworked and they have come out with the new standards of SQL. Okay, I think in the new standards of SQL, what we do is instead of writing a query in this particular way, so we write it like this. We just say select the columns from the table, and instead of getting this multiple tables using a comma separator, so we specify a join keyword. Okay, it is like a more of English language you're using. So we are clearly telling, oh, we are joining between the products and the categories table. Now, when you use a join, always a join needs a logical relationship. Okay, we need to have a link. So to define the relationship, we use the on keyword. So join needs an on. Okay, so now when you run this, you'll get the same output what we saw, but this is a better way of writing. So meaning is more clear. Okay, we are not filtering the data, we are joining the relationship. So we just say how we are relating. So using an on keyword, and what are the tables based on which you're joining, you're defining using the join keyword. Okay. Now, further you want to filter, I want to see only the products which is costing more than $50. Okay, so your job of where will be where it's like a filter. Where is used for filter? Is it where I say product.unit price is greater than 50? So this will show me only those particular products. So whose price is above 50. Good. Okay, we have a very clear meaning in this particular type of join. So we are telling, okay, what are the columns, and the columns which is common in both, we have to use a fully qualified name. Right? And on is used for defining the joining condition. So join is a keyword to specify. So between what are the tables you're joining, the meaning of where will remain the same. Okay, whatever you used to filter the wheres, we can use it. Again, is optional. If I'm not giving the where, that means you're not filtering. Okay, you're trying to get the complete data. That's it.
In the previous comment also, we could after.
Okay, this is a simple join. Now we have different types of joins. As said, we have an inner join, we have an outer join, we do also have a self join. So we'll try to understand this. As the name says, inner join, it records from two tables are combined, okay, and added to the query's result only if the rows from both the tables match based on the common column. So that means it is going to show only the records which is matched based on the common column. The records from two tables are combined and added to the query's results. That means output mate will be displayed only if rows from both the tables match based on the common column. This is what happens in the case of inner join. So only the common data will be shown from both the tables. Now, how do we define the inner join? Now, by default, it is an inner join itself. So you want to define the inner join. I'll just say the keyword called as inner join. That's it. Sorry. Okay, so when you say inner join, okay, it is an inner join. That means if I'm not specifying this also, by default, it is an inner join only. So what exactly happens? It shows only the common information from both the tables. So how do you check? Now, let us see an example here. In my categories table, I have 8 different categories. Okay, and in my products table, I have 77 rows, 77 different products. And you can see every product belongs to some or the other categories. Let me see in the products table, which of the categories still we have the products. If I have to know for which of the different categories I have a product, what should I do? I can use a distinct keyword, no? Select distinct category ID from products table. So if I say distinct, that means what all the categories are there, the repeated value will be shown. So that means in my categories table, I have 8 categories. Okay, and you can see I have products for all the 8 categories. Fine, so it will show me all the products. Now let us do one thing just to understand this inner join. I will just add a new category. Okay, so I'll just go to my categories table. Let me add a new category here. I'll just right click on the category, edit top to 100 rows. So where I can see the categories, let me add a new category. What is that? We'll add a new category. I'll just say something category called as electronics. Okay, electronics, what happens? You get a TV, we get a refrigerator, etc. Okay, so the description, okay, image, let us not have the image. If you want one more category, as I say, fashion trends, no? Yeah. Fashions, okay. So it can be clothing, Indian, Western, traditional clothing, or whatever it is, fine. So I just added two new category. So that means in my categories table, I have totally 10 categories. I have just added two new categories. But in my products table, I just have products only for category 1 to 8. For 9 and 10, I don't have any products. Now, when I use this particular inner join, so now what happens? This new two categories will not be shown because this category ID is not matching category ID. This 9 and 10 is not there in the products table, so it will not be shown. So you can see here, so we have totally 77 products, and the output of your inner join, we can see still it will show as 77 only. Okay, so it is showing all the products with the matching category. It's showing all the products with the matching category. Now what I will do is, for our understanding purpose, okay, so what I will do is I'll try to add some data into my products table. I'll right click, I'll just say edit top to 100 rows. I'll add a new products table here. So I'll add a new product. What is a product? We'll add any product. Mobile. Okay, supplier, some supplier, I'll just say, cool. I'll not give the category ID. I'll just purposely, I want to keep it blank. Okay, and I'll just say quantity per unit, I'll just say 1. Okay, I say unit price, something like, 6,000 or something. Okay. And say units in stock, I have some 50 pieces. Okay, so all these are optional. Let me go ahead. This record has been added. Okay. Now, when you go to this products table here, I have 78 products. I have 78 products, and you can see here, this mobile, I have not given a category ID. There is no category ID. Now, when I use the inner join, what happens is it will not show it is still showing as 77 rows. That means that mobile, since I have not specified the category ID, so there is no matching record from that table. So that record itself is not shown. And other two categories we added in the categories table, but we don't have any products belonging to that. That record is also not shown. So this is what happens in the case of inner join. That means it will get the record from both the table only based on the common column available. Okay, so I think, hope this particular definition is clear now. So record from two tables are combined and added to the query's result only if the rows from both the tables are matched based on the common column. Fine, sure. Clear? Okay. Next is, we'll see with the outer join. When I say outer join, the definition, let us see. Returns all the rows from at least, returns all the rows. You can see return all the rows from at least one of the table mentioned in the from clause, as long as if you have not filtered using the where clause. So it means, see, in the case of inner join, it was showing only the common information. Okay, but here in the case of outer join, it will show the common information. Whatever the common information, it will show. But apart from that, okay, you want to get the data at least from one of the table, the complete data from one of the table. Okay, we call that as an outer join. Okay, so returns all the rows from at least one of the table. It might be from both the tables or it can be one of the table. That means either from the products table, I want to show all the products, even though they don't have a matching category ID, I want to show the products, or I want to show the all the products in the matching category, and I want to see even the categories for which I don't have any products, I want to show that categories also, even though they don't have the products. In that case, we'll go for the outer joins. Okay, so now based on that, we have three types of outer join. So we have what is say left outer join. Okay, we have a right outer join. We do also have a full outer join. Okay, so we'll just see one by one. Okay, so first we'll see with the left outer join. What a left outer join will do, it returns all the records from the left table and only the matching record from the right table. That means it is going to get the complete data from the left table and only the matching records from the right table. Okay, so let us do it in this one. Let me rewrite this query. Yeah, so when I say left outer join, instead of inner, I'll just use this as left outer. So what I have done here, instead of join or inner join, I have used a left outer join. Now, when you see in this query, we have one table which is on your left hand side, and we have another table here which is on the right hand side. In between is the joining condition. We have one on the left hand side and one on the right hand side. So when I say left outer join, it is going to get the complete data from the left table and only the matching data from the right table. That means I want to show all the products with the matching category, plus if I have any products which doesn't have any category ID, still I want to show that products. Okay, so now if I run this, how many rows we can expect here? 78. Yeah, so you can see totally it says 78 rows. Okay, and when you look into this, it is showing all the products with the matching category ID. Plus, you can see here, we just added this new product mobile. We did not specify the category ID. We did not specify the category ID. So there is no category details, but still this product has been shown, which was actually not shown in the inner join. We are able to see this in the outer join. Since we said left outer join, it is getting the complete data from the right table and only the matching data from the right. It is getting the complete data from the left table and only the matching data from the right table. Clear? This is what we call it as a left outer join. So where do we use this? So I want to see list out all the products, whether it is being supplied by the in-house supplier. So that means like, feature group, they have their own products as well as they get the products from the external vendors. Now I want to see all the products, which is my own products, which does not been supplied by an external supplier. Plus, yeah, if the product is being supplied by the external supplier, I want to see even the supplier details together. So in those kind of a scenario, we use this particular left outer join. Clear? In what kind of situation we can use it. Next is, we do also have what we call it as a right outer join. It takes two tables and joins them together based on the linking. So it is same like your left, but it shows the matching data and the complete data from the right hand side table. Okay, so I'll just change this left to right here. This is going to be a right outer join, so which is your right table here. Okay, which is on this side. So that means it will show me the products with the matching category. Okay, it will not show that other product which doesn't have a category ID, which will not be shown. But we have some categories for which I don't have any products. It will show me that categories also. So when I run this, so you can see here all the 77 rows. All the 77 rows, that is the product with the category has been shown. Apart from that, we do have these two categories for which I don't have a product. Still that is being shown. So I just want to know for which of the categories I don't have any products. So tomorrow those categories I want to remove. So then I don't have the products, I don't want to maintain that particular categories. Like today I don't have some, I have some courses, but I don't have any students for that. So I want to make that as absolute. Fine. So before I could make it absolute, I want to cross check it. Yes, do it. Okay. You want to list out only those particular what do you say, categories for which I don't have any products. We can just use this where, no, where say product ID is null. So in this case, what happens? This will show me only those particular categories for which I don't have any products. Very easily we can extract it. Because I wanted to see the categories for which I don't have any products, which we need to take the help of 2 tables and then only link. Yes, we are able to do this. Clear? Okay, understood about the left and the right outer join. Now the same way, see, like as I said, apart from the normal join, we can use a where clause for filtering. Whatever we have studied in the select statement with a where clause, all those commands can be used. Now the next thing here is we have a full outer join. Full is what? It is going to get the common information, all the products with the matching category, yes. Plus, I have some products which doesn't have a category ID, it will show me that. I have some categories for which that category ID is not referred in the product, even that will be shown. That means the common information plus the complete information from both the tables will be displayed. That is your full outer join. So you can see here, this is the records which we have in a product data, but we don't have a category that has been shown. And this is, it is showing all the products with a matching category is being shown. Plus it is also showing, okay, all the categories for which I don't have any products, it is showing all the 3 values is shown in this. So that is what we call this as a full outer join. So that means matching information plus the complete info. That means with the match you want to show the data. But apart from that, I want to see, okay, if there is any categories with me for which I don't have a product, let me show that also. If I have some products which for where I have not assigned for any category, let me see that also. Okay, so I want to see all those data. So we use a full outer join. So we have seen with the inner join, we have seen with the outer join. So in the outer join, we have a left, right, and the full outer join. So understood? In the case of outer join, it gets the complete data, matching data, plus the complete data either from the left table or right table or from both the tables based on the type of outer join that you are using. Next is, we'll see with what to say, self join. The next type of join we'll see is your, we have seen with the left, right, and full outer join. We'll see with the self join. As the name says, self is nothing but a join within the same table itself. See, now for a join, we need minimum 2 tables, and there should be at least 1 common column between both the tables, based on which you can create a relationship. But when I say self-join, as the name only says self-join, means it's a join which joins within the same table itself. If you want to join within the same table itself, that is where we use a self-join. A self-join is a type of an inner join. It can be anything. It can be an outer join, inner join, or anything. Used to find the records in a table that are related to the other records in the same table. Okay, it is used to find the records in a table. Okay, you can see self-join is a type of a join. So I can say it can be inner join or outer join. Used to find the records in a table that are related to the other records in the same table. Within the same table itself, the relationship is trying to create. So I can say example is a primary key and the foreign key is in the same table. That means like a foreign key is referring to a primary key within the same table. In that kind of situation, we'll be using a self join. Okay. Let us see with examples. Okay. Now what I will do for this is I need to have a table where we have a primary key and foreign key, which is happening within the same table. Link is happening within the same table. So we do have it. Yes. We have a employees table. We do have this employees table. So I'll just take the help of this employees table. When you look into this particular employees table, what is that we have? We have an employee ID. We have a first name, last name, the details of this particular. You can see I'm just trying to write this particular query here. So that is the employees table and has the employee ID, first name, last name, title, hire date. They have all the personal details. And you can see here, we do also have this information here called as reports to. You know what is this reports to? This reports to what you're seeing is nothing but is the employee ID itself. But that is the employee ID of the respective managers. So this employee is reporting to employee ID 2. This employees, again, all these employees, Janet, Margaret, and all this thing, they're reporting to the employee whose employee ID is 2. Okay, now who is this 2? So many people are reporting to him. So if I have to find out, I will just go back again here. Oh, 2 is nothing but Andrew. That means Nancy, Janet, Margaret, since they are reporting to 2, so that means they are reporting to Andrew. All these people are reporting to Andrew. That is, Andrew is employee ID. Yes. Okay. And he is a vice president for the sales. That is the reason everybody are reporting to him. Okay. Now, when you look into this particular Robert, okay, is reporting to whom? 5. Who is that 5 there? 5 is Stephen. So that means Robert is reporting to Stephen. That means Stephen is a manager for Robert. Michael and Robert, they're having reports to us 5. So that means Stephen is a manager. So that means what you understand from here, an employee is a manager to the other employees, and that manager is again an employee to the other manager. Okay, is a hierarchy happens in the organization. No? We have a CEO, and then we have some functional heads. Under that, we have some executives. So we have executive heads. Under that, sub executives. So employee will be reporting to an executive head. That executive heads will be reporting to the department head. That department head will be reporting to CEO or director or whatever it is. So now what happens? Even executive head is also an employee. Department head is also an employee. Manager is also an employee. Even a CEO is also an employee. So we have not maintained a separate table as manager, separate table. No, because employee itself is a manager, and again he's an employee again for somebody else. Okay. So in this kind of situation, now what I want is, the query I want to see to whom they are reporting. Like say example, I wanted to know like who's the manager for Robert. So what I did, I just traced there and said reports to us 5, and then say, oh, a manager for Robert is Stephen. I want to see this as one option. See, we have only 9 employees here. So I have to do so much of exercise to get the reporting manager. And manual work is not error-free, no? Okay. We cannot rely as unreliable. Yeah, I think. So now what I want is, okay, and just imagine if you have thousands of employees, lakhs of employees, and there'll be a huge hierarchies, multiple designation, multiple hierarchies and all this stuff. So you have to get it. So same queries can work even for an amount of data. Now in this kind of a situation, so what is that we do? What I will do is, just for our understanding, I'll just take only the data what is needed. I want to avoid this scrolling from this end to that end. So because I don't need birth date, hire date, and all these things, I'll just take employee ID. I'll take the first name, I'll just take it. Okay. And I'll just take the report. Sure. I'll just take only this data. When I run this, I've just taken a small subset of the data. Okay, where I've just taken only the employee ID, first name, and the reports. Now we can easily know that Nancy is reporting to 2 means Andrew. That means Nancy, say this people, Janet, Margaret, Stephen, and Nancy. These are reporting to 2, that, and also Laura. They're reporting to 2. That means they're reporting to Andrew. And when you look into Michael, Robert, and Annie, they are reporting to 5. What is 5 there? 5 is nothing but Stephen. So these 3 people are reporting to Stephen. Stephen is a manager and Andrew is also a manager. Now again, Stephen is also reporting to 2. That means, okay, Annie is reporting to Stephen and the Stephen is reporting to Andrew. This is how the hierarchy is going. Now, fine. I just want to know the employee name and the manager name next to that. Okay, so I just want to have a manager name next to this. I don't want to do that manual exercise and carry it. No, I just want a query which is going to show that. So that is where exactly we'll try to create a self-join, because we have this is a primary key. Okay, and this is your foreign key because it's a copy of primary key here. The same employee IDs are there. Okay, but here we can see we have a repeated info. Here we cannot have a repeated. It's a unique. Every employee will have a unique ID. But what happens? There might be multiple employees reporting to the same manager. Okay, so reports to can be repeated. So reports to is like a manager ID. Okay, so now what I will do for a join, I said we need to have minimum 2 tables, and there should be at least one common column between that. But here I don't have 2 tables. I have only 1 table. So what should I do? I'll try to fool the compiler. It's like, you know, you go for jewelry shop. What happens? Right round, they'll put the mirrors. So if the shop is this much, it should looks this much. And the reflection, it goes something like this. Is it? You see everywhere go like this, everywhere like this. Is it? They're fooling you, is it? Okay. Now we'll fool the compiler here. We'll say, no, no, see there are 2 tables. Actually, it is only 1 table. So what I do, I'll just try to put a mirror. I try to create another copy of this. Let me do some small exercise. What I will do is I'll just try to create something like this. I'm just trying to show and explaining. I'm just assuming virtualizations. To do a lot of assumptions. I have 2 tables now. Okay, it's something like, you know, I've just kept a mirror here. The same table I have just copied and pasted. Fine. Okay. Now what I will do is for a join, we need to have minimum 2 tables. Here I'm telling, oh, I have 2 tables. See, in your database, you cannot have 2 tables with the same name because I don't have physically, I don't have 2 tables. Okay, but what I'm doing, I'm putting a mirror. It's a virtual person who's been displayed there, is that? So virtually they are 2 this one. So we cannot have 2 tables with the same name. I'll try to give a different name. I will consider this table, which is on the left-hand side, as the employees table. In short, I can say it as E. And I'll consider this is the manager's table. I'll consider this as M. The table name as, I will consider it as M. Fine. Now what I will do is from the employees table, I'll try to get the employee ID and the name. Then I need to get the manager name. If I have to get the manager name, what will I do? Oh, he's reporting to 2. So who is 2 here? I'll link this manager to this employee ID and try to find out what is 2. 2 is Andrew. Then I say, oh, Andrew is the manager for this Nancy. Yeah. The same way, this Janet, Margaret, Stephen. Okay. This employees 3, 4, 5, they're reporting to 2. That means they're reporting to Andrew. The name of the manager for whom these people are reporting is Andrew. The same thing happens here also. We are just linking and trying to extract. Now the same way, if I just take this particular data, Michael and Robert, they're reporting to 5. Who is 5 there is nothing but Stephen, is it? So these people are reporting to Stephen. So even Annie is also reporting to Stephen. I want this. Okay, so let us see how do we do this. Okay, so what is that I need to do when I write a query is very simple. From the E table, okay, I'll take the employee ID and first name, which is the actual employee details. And from the M table, I'll take the first name, which is going to be the manager name. And how I'm going to relate this? I'm going to relate this based on this product ID of the employee table will be related to the employee ID of the manager table. Simple. Problem is solved. Okay, sure. Now if I have to do that, so my query will go like this. Select from, so I'm taking 2 tables, that is both the virtual tables. No, I'll just, there is actually only one table called as employees, but I'm going to refer this as E, and I'll just say join that with again employees table itself, because I'm joining with the same table itself. Okay, one I'm considering as E, that is on the first left table E, and the right hand side table M. Fine. Okay. Now both the table has the same column name. When they have the same column name, you have to use a fully qualified name. So I'll just say from the E table, take the employee ID and first name. They are the actual employee details. And from the M table, take the first name, that is going to be the manager name. So this one will be from the employee table, take the employee ID. Okay. From the employee table, take the first name. From the manager table, take the first name. No, first name 2 times is there. I'll try to give alias name telling this is manager name as manager name or something. Good. Fine. from these two tables. Now, how they are related? We have to use on. Okay, what is the relationship here? From the employee table, I'm taking a reports to and linking to the employee ID of the manager table. So what I need to do, I just say E dot reports to is equal to M dot employee ID. That's it. Got it? So we can see all the employees with the respective managers. So Nancy, for whomever they're reporting there, okay, the people reporting to Andrew. So again, Laura is also reporting to Andrew, whereas Michael and Robert and Annie, they're reporting to Steve. Problem is solved. Okay, we have the employee ID 2, that is Andrew. He is not reporting to anybody since we have told the inner join, so there is no matching data. So that is the reason. So you want to show that also employee, we can use a left outer join. When you use a left outer join, what happens? It will show me that manager also, because this person, he doesn't have any heads. Okay, so I'm trying to get the complete data from the employees and only the matching data from the manager. That means he doesn't have a manager. Still, I'm able to. Okay, it is just a simple join. There is nothing called a special thing called as a self join. No, it is just a simple join, which can be inner join or outer join or anything. But here we are trying to join within the same table. Okay, so, but still, you know, for a join, we need minimum 2 tables. We are telling the compiler, okay, consider this as 2 tables. You consider this as one alias name, this as another alias name, and then try. Okay, for that, we need to have a foreign key referring to a primary key within the same table. So this is what we call it as a self join when it is when a join is happening within the same table, employees table, or within a single particular table.